Hello folks, this It's Elementary video guide is designed to supplement the It's Elementary written guide, which provides all project details that include a project summary, key vocabulary and background, materials, procedure and design criteria, activity extensions for students who need more, activity scaling to differentiate instruction, and the conclusion. The video and written project guides assume an audience of non-engineers. Let's get started. This lesson introduces students to the world of artificial intelligence by showing how Boolean algebra, which is a system of symbolic logic, can be used to represent rules in a virtual world, like in a video game or simulation. Teams of 3 to 4 students will then build and present their own virtual world by using Boolean algebra to create a consistent set of rules based on propositions, which are statements that affirm or deny something, and implications, which are logical judgments based on evidence and prior observation. Now, approach here is a creative variation on tryengineering.com's Boolean algebra is elementary lesson. Let's consider vocabulary and background over there. First term is artificial intelligence. Let's define artificial intelligence as a branch of computer science that deals with writing computer programs that can solve problems creatively. Any video game is an example of artificial intelligence. What Mario and his brothers go through, what Zelda went through to become a legend, even what Pac-Man and his family went through to achieve their exploits. These are all examples of artificial intelligence. Next up is Boolean algebra. Boolean algebra is a system of symbolic logic. It uses operators that allow us to build and state propositions in logical fashion. Then a proposition is a statement that affirms or denies something. I think, therefore I am. That's a proposition. Implication. An implication is a logical judgment based on evidence and prior observation. I am awake, then I must be doing something. It's not the best implication ever, but it's an implication. All right, let's talk Boolean algebra operators. Check out my little table there. We're going to talk about 4 operators. We're really going to talk about 3, and then I'm going to apologize for not talking about the 4th one that much, but I'll explain. First operator is not. It is an operation of negation. If the input's true, then the output is false. It's contrary. If you see the truth table, wherever input A is true, then the output A is false. Whenever the input is false, then the output is true. Negation. Next operator is and. That's an operator of conjunction. If all the inputs are true, then the output is true. If you look at the truth table, only when both A and B are true is their output, written AB, also true. Next operator is or. That is an operator of disjunction. Only A or B need to be true for the output to be true. But if both A and B are true, then the output is true. Now, I flew through those first 3. I'm going to have to do a little hand waving on the 4th one. The 4th one is implication, where A implies B. The truth table there is, by mathematical definition of implication, it makes no personal sense to me. It never has. In 30 years of studying this stuff, I have just simply accepted it to be what it is. But in natural language, an implication is best illustrated by the if-then construct. If I am awake, then I must be working. If I stand up, then I am able to walk. That's what implication is in a real sense. Let's talk about propositions and implications by providing some samples. So I'm going to show a set of cards over here that provide all the combinations of propositions and implications for this virtual world that I have defined. Let me talk to you about how I build it, and then talk to you a little bit about what those propositions and implications mean, what they don't mean. So I choose two propositions for this virtual world of mine. One is that equality depends on opportunity. I call that proposition A. Second proposition is that equality depends on circumstance. So I am going to build my entire world on those two propositions. Proposition A, equality depends on opportunity. Proposition B, equality depends on circumstance. Now, what I do from here is I set up all of the possible combinations and propositions, whether they're true or not. I'm not worried about that yet. I want to simply enumerate all the possible propositions and implications, because what a video game designer does is once they define a world, they create all the possible propositions and implications of that world through combinations, and then they decide which ones are true. They eliminate the ones that are not true. So in similar fashion, I use the and, or, not, and implication operators to enumerate all 16 possible combinations of the propositions and implications for my world. And you see a few of them here. I'll talk about a couple of them there. I have not A. Not A negates equality depends on opportunity, which turns it into equality does not depend on opportunity. A, B will conjoin that equality depends on opportunity and equality depends on circumstance. Now, I hope that makes sense here. I just want to enumerate all the possible combinations using my basic propositions and my Boolean algebra operators. That's what I'm doing there. Now I'm only showing you some of the propositions. There are a total of 16. I'm showing you 8 here. Right? Let's keep moving. You want to use these cards to model and create your own teacher set of at least 16 cards. Now, this exercise will develop your skills in helping the students to create their own set of cards. This is important. Having the students create their own cards will allow them to build a world of interest to them, which will facilitate a powerful learning experience that may exceed the boundaries of the lesson, which I'm already introducing if you have gleaned some insight from the world that I've defined. I've defined a world that is very important to me, because in my study of these phenomena, when the world offers you no personal connection, it's kind of hard to wrap your mind around all of the ideas being espoused here. So that world of interest is very important, and they're not the easiest things in the world to build, so you want to take some time there. So my example cards above have constructed a virtual world whose rules consider themes of social justice because they are important to me. The equality theme presented, it's what we call a false dichotomy. This notion that either A or B is true and no other alternative ideas are possible. These false dichotomies are very prevalent in our world. And similar example worlds can easily be constructed using their prevalence in society. There's one that says people are either introverted or extroverted. There's one that says extroverted people are good, introverted people are bad. Another that says, hey, you're either part of the problem or part of the solution. Another that says, hey, you are either with us or you're against us. Now, these dichotomies provide concrete ideas which may make it easier to generate all these combinations and propositions and implications for a virtual world. But you got to be careful, because these concrete ideas may also spark disagreement amongst students. I'm sure there are less polarizing examples that exist, but none of them captured my imagination and resonated as much as these did. But feel free to find your own engaging topics. My role here is to be a guide and resource for ideas, and to encourage you to go in your own direction. Let's talk materials. Each team will be provided paper. And I like to provide this paper in the form of the engineering notebook, which allows the engineer to record thoughts and ideas and data over time and become a valuable resource before, during, and after camp. And then there are also a set of index cards. I'd say about 30 cards for each group of 3 to 4 students. And that's it. All right, now let's go to our procedure. Depending on your student and teacher backgrounds, you may want to view a very rich set of propositional logic videos provided in the lesson. Links to one called The Basics, there's one called Truth Tables, and these are all very short. And then there's one devoted to each of the Boolean algebra operators: not, and, or, implication. Remember what I said before about implication? Now, implication is kind of hard to wrap your mind around in a mathematical operation sense. It's real easy to understand in natural language. Having a teacher-led classroom discussion, though, may reduce confusion with these logic rules, notation, truth tables, and all the technical definitions. There's some technical stuff here, but it can be considered and explained in very logical fashion. It just may help to have the iteration. You may want to use the videos. You may want to reinforce it with a class discussion. But next, assign your students to teams of 3 to 4. At your discretion, present examples of virtual worlds that the students can build, like the ones I've shown you and like the ones you will hopefully add, and allow students to brainstorm and contribute to the list. You can allow them to select their virtual world from this combined list, and it's okay if multiple groups want to build the same virtual world, because they probably won't do it in the same fashion. Have the students create their world using at least 16 propositions and implications. It might be easiest to introduce the world with 2 simple propositions and then create all the combinations of propositions and implications from it. But write each of the items on these index cards, and then have the students write all of the items in their engineering notebooks. Then you're going to do a little activity that I call It's Elementary. If you remember Sherlock Holmes, he liked to say, "It's elementary, my dear Watson." Sherlock wanted to separate fact from the fiction, the true propositions from the false ones. In the virtual world, the artificial intelligence engine, something we call a rule base. Back in the old days, they called it a knowledge base. It decides what happens based on 2 situations: which propositions are true because the engine has been told that they are true, and which propositions are true or false based on implications set forth in the rule base. I encourage you to allow your students to decide through informal discussion and debate which of their propositions and implications are true, operating under the assumption now that they have chosen a virtual world that they have an interest and connection to, and that it somehow translates to something concrete. So let them decide amongst themselves, while respecting the fact that many real-world truths are often subjective. Let that be. in order to allow them to build their world's artificial intelligence engine. Then challenge them to create 3 to 5 minute treatments. In the movie world, these are summaries used to sell ideas for films or games, products, for a video game and or film series based on their rule base. This could be the next Legend of Zelda or Mario Brothers franchise. Now, as an example, here's the final rule base constructed from my sample world. And yes, it's over there. Yeah, I settled on 2 propositions, well, 3 propositions and 1 implication. That equality depends on opportunity, and that it also depends on circumstance. Now, as I get ready to close, consider this treatment for a video game based on my treatment's rule base. This is called the equalizer. Our world is still dominated by forces that equate equality to providing opportunities. These forces often provide opportunities that they control. Imagine that. Now, to the contrary, equality is predicated on both opportunity and circumstance, perhaps more so on circumstance than opportunity. Equality is achieved when societies provide opportunities and circumstances that create diverse, inclusive, and sensitive environments. Those favored most by the status quo are not likely to help change it. The opportunities and circumstances that create diverse, inclusive, and sensitive environments must be procured and created by the people who desire them most. This requires the development of leaders who have equalizer mindsets, those capable of being neutralizing authorities who balance power wherever the deficits exist. Power is work done efficiently, that is, with wise and skillful use of resources, interests, communication, and expertise. Equalizers who generate power and multiply themselves can create change, lasting change. I, ladies and gentlemen, am the equalizer. I cut. How do we extend this activity? Well, we use 2 basic propositions to create our sample list of 16 combined propositions and implications. Challenge the students to begin with anywhere from 3 to 6 basic propositions, hopefully concrete ones, from which they can construct their combinations of propositions and implications. How can we scale this? We can identify and construct a short list of virtual worlds that the students can then choose, as opposed to brainstorming. That may help to streamline and guide the activity a little more, because you're giving your students opportunities to be human in this one. And humans are real people too. So you want to try to keep it all on the rails and keep it directed in a productive manner. Have fun with this one though. This one is challenging, to say the least, and I hopefully have brought some light to it and told you a little bit more about myself and what is important to me. It's not all about engineering with me, folks. Take care.